Thanks for joining us today.
Mhm. I wanted to start off with a quiz while we're waiting.
Oh, well,
People
there
can-
you go. We can start that off. Go ahead, Karen.
Well, you can just think about this. I'll show you the answer in a second, but I'll say this, the answer may surprise you. Surprise me.
I have a thought, but I'll wait to see
Okay.
what the answer is.
Yeah. I mean, like you hear a lot about how the overall amount, the quantity, not the percentage of their portfolio, but the quantity.
Yeah.
So like Texas is generally the leader on the quantity.
Quantity, right.
But
Good
how do they
point.
stack up as a percentage?
All right. Well, we're a couple minutes in, so I think we could go
Yeah,
ahead and
good.
get started. Welcome, everyone. We are here for the Clean webinar. Excuse me, first of the Clean webinar series for the spring semester. We're going to be talking about teaching climate and energy with Clean. We have Karen Kirk here, who's going to lead us through. Karen is a science journalist with the Yale Climate Connections Group and NASA Climate Change, and she's been part of and involved with Clean for a very long time. She knows a lot about the topic, so we're excited to hear from her. And Karen, please take it away.
Cool, will do. Thank you, Katie and Casey, and thanks for coming. So yeah, so let's go back to our quiz. So this is part of climate and energy literacy. For one thing, it never ends, it's never changing. But does anyone have any guesses that you want to put in the chat or say out loud? Because there's just a few of us, so we can talk out loud. Katie, what was you said you had a thought?
I thought Texas, actually, because I knew the amount, but I actually do know that they have a pretty significant percentage too that's coming from wind and other things like that.
Right.
So
it says
that was my thought.
Says the chat is disabled. Thank you, Lori. You can unmute yourself and chat and speak if you want.
Oh, the chat shouldn't be disabled. That is weird.
Oh, that is weird.
Let's see. Wait, I can let people, and I should be able to let people unmute themselves.
Oh, okay, that's okay. I don't want to hang up too much time because I know we need to finish on time today. But anyway, the answer is South Dakota, surprisingly. And so this is just the electricity that's generated within that state, not necessarily what they use because electricity crosses state lines. But South Dakota, if you look at the way they have grown their wind energy, it is absolutely inspiring. They from if you start about 4 years ago, they basically doubled it and then they doubled it again. Actually, in 3 years, in the span of 3 years. And it's not a state you hear about being particularly progressive. It's not a state you hear about being particularly wealthy. They are just doing it. And so I think way to go, South Dakota. I live here in neighboring Montana, and we tend to lag our neighbors. And so it's always interesting. I love state by state maps because they allow some states to really shine, and they allow a little peer pressure to the neighboring states. And I think this is good. So what's our point here today? That was just a warm up, but basically Clean is here to help you teach climate energy and be as awesome at it as you could possibly be. Today, we're talking about what we call the climate and energy literacy principles. And that's kind of a mouthful, but it's ways to slice through these big topics and make it easier to understand, easier to stay up to date, and easier to teach. Because why? Because it's always changing and it's full of misinformation. No matter, as soon as we advance one thing, then we have the next bit of misinformation. And so it's always changing, and we've got your back. We're always here for you. This is just nonsense, like quackery on the left side here. And then, so it's like there are two graphs of the same thing. One's real, one's fake. Like, how am I supposed to know the difference? And, the moral of the story is, we're here to help you. If it's in our collection, then it's legit. The misinformation thing is a constant problem. And so you're always having to stay up to date. So this is actual tweet from an actual senator last winter talking about how this Texas ice storm, could be devastating to Montana. Well, the most reliable energy sources weren't gas and coal. So there's a constant pushback to this misinformation from a supposedly credible place. The fossil fuels failed just the same. A lot of fear mongering about, oh my gosh, we're just going to die if we don't have fossil fuels. And then, of course, fake stuff. This picture has nothing to do with what happened in the US. So It's a tough environment. On the other hand, it's really inspiring. There's as many failures, there are victories, and they come from unlikely places like South Dakota. And it's amazing to watch the resurgence of the younger generations is really taking this head on. And you're certainly never going to get bored, because every world event has, not every, but so many of them are coupled with energy and climate, because energy and climate are part of everyday life, whether it's how you're getting around or what you're eating or what you're doing, where you live. So they're really like unified throughout our lives. And so you shall not get bored. There's some great examples of people in our field, educators, being brave here, like learning this stuff alongside their students. And the students, because of the misinformation and how relevant it is and how political it is, you're going to hear pushback. And this Kelly Grabowski, she did a great job. She was like, all right, I had to step up. You know, she didn't get a ton of preparation in her degree and her education. And so she stepped up sort of hand in hand with students, and that really brought them on board and made it gave her more credibility than if she were just this sort of authoritative kind of thing. So we can all grow and learn together, because it's going to keep changing. So what are we doing here tonight? We are going to go, just a quick run over of what CLEAN has. We have a lot of this teaching guidance. That's what these webinars are about. It's linked to our collection of free teaching resources, which is also always growing and changing. We have lots of people working on this, and we would love for you to join us, and lots of ways to find what we have. Okay, so here at the bottom, this orange arrow, if you go to our website, you see this Explore Teaching Climate and Energy, and that's where we're going. We're going to give you a sort of a tour. You would come to this spot, and you've got Teaching Climate and Teaching Energy. Let's go the other way. These are two just screenshots side by side, but this is what you get if you do the Teaching Climate side and the Teaching Energy side. And what it is, it's a sort of drill down through these literacy principles, and we're going to step through those. So each one of these principles, let me back up a sec. Basically, these are ways to take these huge unwieldy topics and slice them down into easier chunks, certainly easier to teach as well, because they're sort of organized ways of thinking about it. So each of these pages is laid out the same. So once you've seen one, you've seen them all, and you can navigate quickly. We have these big principles at the top, the big idea. Then you get the fine print. Sort of, if you expand this, you get lots of fine print, but you might not need all that fine print. Right below that is a summary, just in sort of everyday language, try to be just easier to read. And then the scrolling down, then you get into the classroom part. So how do you, what do students need to know? Where might they be confused? What are some ways you can tackle misconceptions and general teaching strategies? Getting more specific as the page goes down, how to teach this, what are some ways to pedagogies and strategies, how to teach it. And then examples. Some of our favorite handpicked examples, but the collection is always growing. And so use these search buttons and go in and dig and look for what you actually want. This is just a teaser of what's actually in. So that's every page. So now we'll go through these concepts, starting with climate, just like a quick overview. But what I want you to think about is, what do you need? What's your role as an educator? What's your audience? What are your topics? And think about the sections here that apply to you, because they're not all going to apply to everyone, obviously. So if we start with climate, the basics of climate has to start with the sun. That's kind of our number one climate maker. And I love that you get exactly one bullet into climate and energy literacy principles, and you come across your first misconception. The sun is the cause of climate change. No, it isn't. The sun is the main driver of climate. But if we're causing climate change, the sun would have to be changing too, right? And it just isn't. Here's NASA data. So the yellow line is solar irradiance, and it varies with the sunspot cycle. But do you see any trend line in there? If anything, slightly cooler. And then compare that to what's actually happening with the temperature, quite a lot warmer. So those things are not related. So this one's pretty easy to refute, because it's like, hey, yeah, you know what? We've actually been measuring the sun, observing the sun for like hundreds of years. And we know pretty well what it's doing, given that it's so important to us. And yeah, it is not the cause of today's climate change, but we do know what is. So we'll get to that one. Climate, is complicated. This has worked to the advantage of those who are trying to sow doubt because they say, oh, it's too complicated, right? But I think students can love this kind of stuff because we could break it down again into pieces, understanding how the greenhouse effect works, what greenhouse gases are, how different types of energy can pass in one direction or both directions, et cetera. How Earth systems play together. And then we love talking about feedbacks. We're trying to change our language around feedbacks instead of saying positive and negative, because those have their own connotations. Say something like a self-reinforcing feedback or an accelerating feedback, one where it builds on itself, or ones that cancel themselves out. And so there's some better, easier, maybe terminology to talk about these feedbacks. Life on Earth depends on, is shaped by, and affects the climate. You can't separate climate and life. And there's so many ways you could talk about this. One that I love is, why is CO2, it goes up over time, but then every year it does an up and down, winter, summer. And so that's pretty cool. That's entirely driven by life, photosynthesis, drawing in CO2 during its growing season, and then exhaling, basically releasing that during the non-growing season. And the Northern Hemisphere being more land mass, more plant life, dominates the global cycle. So pretty cool seesaw pattern, just caused by the, it looks like the great breathing of the planet. It's really cool. And that's separate from the uphill trend. If you go way back in geologic time, life shaped climate. Life gave us our original oxygen-rich atmosphere. So life and climate are completely intertwined. Mass extinctions are often driven by climate. Today, we're seeing things like fires and insect outbreaks and changes in agriculture, all related to climate, and vice versa. The more things burn, the more that pumps carbon into the atmosphere, et cetera. So it's a sort of two-way street of life. What it also means is you can teach a lot of this from a life sciences perspective. You don't need an earth science or even environmental science class. Climate varies. Yes, climate varies over space and time through both natural and man-made processes, both. Okay, so the biggest misconception in all of climate change is the climate has changed before. Yep. The people who tell you that are basically earth scientists and climate scientists, the same people that are telling you that it's changing now. There are more than one reason. There's more than one driver of climate change. We don't need to narrow it down to one cause, because that's just not how the world works. I love analogies, so you can use, I also at NASA wrote one of these rebuttals. It has to do with, like, you wake up and the lawn is wet, but how does the lawn get wet? Does there have to be only one reason? No. Same with forest fires. They occur naturally, but they can also be caused by people. So just because it can be natural doesn't mean it always is natural. The key thing about this is actually the last statement, which is that we used to sort of have this like arm's length treatment with misconceptions. Like, if we don't mention it, we won't get it creating confusion. We'll just stick to science. Social science research has illuminated that doesn't work, because students are going to see this misconception. And so we're going to inoculate them. We're going to prepare them so that when they see the misconception, they go, oh yeah, I heard that. And so we can't do that with every possible one, but the ones that are really obvious, I think it's our due diligence to make sure we cover that they're going to hear this, and here's how they can deconstruct it. How do we understand earth science and climate science, and how do scientists know what they know? So we know it from observations, from sort of the theory of how the world works, and modeling. And this is really fun to teach because this is getting students involved. One thing that does not go well is a sort of authoritative approach of like, I'm a scientist and that's how it is. Nope, let's do this together. And so have the students side by side with you, learning from their own experiences how climate scientists have learned about the climate. So, you can use local data, you can be making your own measurements, you can be measuring climate data, energy data, practicing science communication and things like that. So it's really, it invites everyone to be involved in this process, because we need everyone here. And this has come from on high, it comes from everybody. This is really important. This is probably the most important one. Human activities are impacting the climate system, period. This is not a like maybe, or like some of this and some of that. There are so many lines of evidence that all point to the same conclusion. And in fact, the warming that we have observed is entirely due to humans, all of it, because on its own, Earth's sort of natural system would be trending towards mild cooling. But in fact, it's like what we saw with the sun. But in fact, what we're seeing is rapid warming. All of that is humans. So it's none of this like a little bit or, maybe a mixture. It's us. However, that treads very closely to being blamey. And so blamey kind of puts us on our heels. I don't want to do that, sort of throws up like red flags. And so we think of how awesome science is and how awesome it is that we've got this really tough problem, but science has found a way through it from lots of different types of studies, lots of different fields, lots of different people all over the world. Impressive collection of scientific knowledge, probably one of the most important questions of our time. So you could talk about the awesomeness of science, kind of skip over the blamey part and then get to the let's talk about this. How do you feel? Do you have doubts? Have you heard otherwise? Does it scare you? Where's your uncertainty? So make that welcoming environment so we can sort of, again, learn together in parallel rather than from the top down. Solutions, even though this isn't talking about solutions, there's no wrong time to bring in solutions because it helps provide hope and optimism, and it's constructive, and it can kind of help dispel some of this blamey tension stuff. Solutions are cool to debate, but this particular topic should not be debated because it's been debated, and we have amazing science, and we want to rest on that and emphasize that rather than infusing debate into this, because the debate at this point, the remaining debate is pretty much in bad faith, and so we want to be careful not to inadvertently let that into our teaching. Climate change has consequences for the Earth system and for human lives. Obviously, right? This is everywhere. Nice to use local cases so that not everyone cares about bears as much, glaciers and things like that. So what's going on in your area? Again, students can be very involved in measuring this. That cleans the STEM Flash emails do a great job of pulling together resources around themes as natural events happen. And again, solutions, lots and lots of solutions so that we don't feel so hopeless. This topic will come around again in 2 weeks. Also, this one's also taught by me for another webinar that just focuses on this and how to weave those solutions in while also confronting some of these consequences. Yay, humans can take actions to reduce climate change and its impacts. Thank goodness. Imagine if we couldn't. That would really suck. People are worried about the solutions, for whatever reasons, usually ideological. But what we should really be grateful for is that because we're the cause, we are also the solution. Thank goodness. This is not some sun explosion or some asteroid or anything like that. It's us. That means we can fix it. So good. We can mitigate it by polluting less and putting out less greenhouse gases. We can adapt to it by being ready for sea level rise, the drought, things like that. We have to do both. The more we mitigate, the maybe less we'll have to adapt. The longer we wait on either, the worse it will be. The more it will cost, the more there will be suffering. So this is a challenge of our lifetime, and your students are going to be part of it. And there's something empowering about that. And taking action definitely feels good. So it's when no matter what you're teaching, if it starts to get come to this one, it's our problem, and that's good. We can solve it. Climate literacy quiz. This is cool. This is a quiz that goes through 20 sort of commonly either understood, misunderstood aspects of climate science. The solutions, then when you do the show explanation, actually give you quite a lot. They give you some data, some references, and then where else in the CLEAN collection can you find materials on that topic. So it's a quiz, but it's also almost a tutorial. And I have it bookmarked because I'm always going back for this little reference I need or whatever. So I think it's a pretty handy resource for you or your students. Switching to energy. I'm just checking our time. We're good. Teaching energy. So these are two sides of the same coin, but it depends how, what your interest is, where you live, what you're teaching. But energy has the same set of literacy principles. So you pick what works for you. But boy, what even is energy? Yeah, good question. Everybody uses, not everybody, but the word is used many different ways. And so it's important just to say that, even to just establish a little bit of this sort of scientific concept around like what energy really is. It's a physical quantity, and energy follows certain physical laws. We don't need to dwell too much on that, but basically energy is in everything. The physical processes on Earth are showing you energy moving through the Earth system. And so you see that in waves and wind. And we need sometimes visualizations to help us see that, or even heat maps and temperature and storms. Those are all expressions of energy. This is where visualizations and simulations do great things for us, because they bring these sort of invisible or nebulous concepts and make them visible for us. I love concept mapping for that same reason. Students can really draw out, how things are related. And I also love role playing. And so anything from a carbon atom to a tropical storm or anything else, energy is what's moving through the Earth system all the time. Same with the biological system. Energy flows right through that just the same. So energy from the sun fuels most life on Earth. Energy flows through all life, and then through ecosystems, through our agriculture, through our food, down to the calories. It's a very healthy looking picture as opposed to the chocolate bar sitting next to me, but energy and all of those things. Okay, this is what we really think of when we think of energy. We think of energy sources. Okay, that's part of energy, but it's not everything to do. But maybe this is where we want to focus in, because this is really relevant to climate change. So various sources of energy can be used to power human activities. Energy needs to be moved around in most cases. And so this is what we're talking about. Every year I update this diagram and I think, what has changed? Are we there yet? So this is the most recent one, and compared to the previous one, renewable energy grew by 1%, and petroleum shrank by 1%. That seems discouraging. We are going in the right direction, but slowly. But at the same time, there's impressive investments, and we're kind of building the foundations to accelerate this. Will it be fast enough? Good question. But anyway, this is sort of the talk of energy sources. It's a really fun thing to teach, because even just what's renewable or what's a fossil fuels are great topics that branch into so many other aspects of science or social science. Quantitative skills are essential for energy. We have all the feels about different energy, but man, we need to measure it. So it's a really fun way to be motivated to get into some math. And NGSS all over this stuff with engineering, design, problem solving, communicating. It's like such an awesome topic. Energy decisions, they move out of the scientific realm and into the social, political, economic realm. Super interesting, again, because now you're not confined to your science class. So, why can't we just switch to renewables? And what about nuclear power? So now you're getting into these much bigger issues, much broader issues. And that's how it should be, right? So science is telling us we have a problem. Technology is giving us solutions, and then society has to pick how to do that. Really interesting to teach. And if you like role play and debate and things like that, here's where you teach that. Bring that into, okay, we have this problem, we have these solutions, how are we going to weigh the various things? And this is also good for the sort of uncertainty factor. Like we're very certain humans are causing climate change, and we're very certain about like what forms of energy do what, but we're not very certain about where we're going to go from here. And so this is a good place to show that we don't know everything, but we're going to build off what we do know to inform these more nebulous questions. The amount of energy we use depends on all kinds of factors. Again, we're back to the quantitative angle here, and how much energy is used for different things. Really fun to measure. Students and everybody has incredible misconceptions about things. What's greater or smaller? Charging an electric vehicle battery or filling your tank with gas. There's like no comparison there. It takes way more energy to fill a car with gas than it does to fill a battery, even though they'll go about the same distance. Like there's some really fun math in here. And powering math, because you know the difference between how your energy is used. It's not just good math, but it's going to affect your daily decisions. And the quality of life is also affected by energy choices. So energy cuts both ways. A society needs enough energy to do what it needs to do. But with that energy comes pollution and exploitation, and those can negate a lot of the benefits. And so, yay, we have energy. We also have this horrible, crippling pollution and this tremendous corruption around that energy resource. Really tricky stuff. A lot of this is very geographic. It depends with the culture and the country and what types of resources they have. And so, again, this is like way outside your science class. Reaches into every aspect of life, and great for students to realize, especially Americans, we've got it pretty good compared to some other parts of the world. And it's important, I think, to realize that sometimes too. So good stuff. Energy has a literacy quiz also. We try to keep these updated, and it's amazing, things change so fast. Bear with us, it's not perfectly updated, but I think they're pretty good. They're only 2 years old at this point. So that's the end of the content. Some ways that you can, just some context of how this fits within CLEAN. We have a lot here to help you strengthen your teaching. This educator's toolbox helps you do things. We have curriculum guides from CLEAN. We have ways to manage controversy. Just in case you're wondering, like, I am going to walk in there and say humans are causing climate change, and I'm not going to be worried. And you shouldn't be worried, but you might read this page to set you up with some options. The STEM Flash is a great newsletter that pumps out these topics as they relate to what's going on in the world. Professional development webinars such as this. So lots of different resources in our educator toolbox that you may want to explore. Lots of ways to join us. We're a really friendly, lively group. So we've got our CLEAN network with our weekly conference calls. We've got the STEM Flash emails. If you have resources that you think are awesome, that they need to be free for teaching about climate and energy, let us know. Webinars, CLEAN Ambassador Program. Basically want to help you be a better teacher and help you spread the word about all these free resources. Yeah, and other things. And then we're also at conferences and things like that. And so we have lots going on. Here's what's coming up next. So next week is Make Climate Change Connections Across the Curriculum. And then we have Teaching Climate Consequences, and then hands-on STEM-based energy activities, and then Beyond Doom and Gloom, thank goodness, because nobody needs more of that. So that's the quick rundown of what's coming up. And that is what I have to say. And so let me know if you have any questions or want any more information on any of that. It looks like Katie has been putting all the links in there, so you've got all the references.
Casey has been. Thank you, Casey.
Oh, Casey, nice. Thank you.
Yeah, thanks, Karen. Always good to hear your sort of take on some of this climate and energy information. So does anyone have any questions? I didn't see any come through the chat or the Q&A while you were talking. So nothing to address from previous, but we'll wait a couple minutes and see if anybody has anything they want to put in the chat.
Sounds good. Well, we're going to talk about South Dakota.
Yeah, that was interesting. I'll mention for people too, if they're interested in, we don't do credit for these webinars, but we do have, we can give you certification for the PD time if you need for your teaching, for if your district or administration requires you to have documentation of the time you spent doing professional development. I can provide that. So just email us at clean@colorado.edu if you do want that. But yeah, that was interesting. I was surprised about South Dakota, but it makes sense. They have so much wind there.
Lisa, and they're using it. So yeah, no, I'm going to use that to help maybe motivate some of our local folks in Montana. Nothing like being shamed, because we always look down on the Dakotas here in Montana. So let's get going. Anyway, thank you.
Got a couple thank yous. Yeah, in the chat.
Thanks for coming.